Hi to all of you. Actually, today topic we are going to see about elastic transducers. What is the meaning of elastic transducers? Before getting into this, elastic transducers are generally used for measuring pressure. So for pressure measurement, they are going elastic transducers. There are so many types of pressure measurements we have. They are gauge pressure, absolute pressure, vacuum pressure, sealed pressure, differential pressure. I think you all know what is gauge pressure, absolute and vacuum. So vacuum pressure is in 0 level, right? So this pressure measurement, what is pressure? Pressure, which is nothing but force by area. So the force exerted through the area which is called as an pressure. So the unit for measuring pressure, we have so many measurements: Pascal, PSI, bar, Newton per meter square. So there are so many different types of units we have to measure the pressure. What are transducers? So transducers means which is nothing but either it is mechanical, electronic, electrical or electrochemical devices. The transducer means which is nothing but it's a device which is used to convert one form of energy into another form of energy. So whatever the signal given to the transducer is called input, and the signal obtained from the transducer is called as an output. So the transducers, we have so many types of transducers we have, but here we are focused only the pressure transducers. So the pressure transducers are generally two types. The first one is mechanical and electrical. So the elastic pressure transducers comes under the category of mechanical. So what are the types of elastic pressure transducers we have? The elastic pressure transducers are Bourdon tube, bellows, then diaphragm. So these are the elements are used for converting one form of energy into another form of energy that can be measured easily. So generally for the measurement of pressure, where we are all using. So we are measuring the pressure either inside the pipeline or a container. According to industrial environmental, it's very challenging task. The pressure range is varying from very low, low, high, very high, and the medium, maybe it's in liquid or in gaseous state. And here we are focused on elastic transducers measurement, which is pressure higher than the atmospheric. So for vacuum pressure, if you want to measure, the elastic transducers are not suitable. So only if the pressure is higher than the atmospheric, that can be measured through elastic elements like diaphragm, bellows and Bourdon tubes. And these are all the elastic elements. They are all changing their shape when the pressure is applied. So according to the change of the shape, it can be measured via a deflection transducers. So these transducers actually we are going to see now. So the elastic pressure transducer comes under the category of mechanical, Bourdon, diaphragm and bellows. Those are the three different types. So the first topic we are going to see Bourdon. What is it Bourdon tube pressure? So for local indication, the people used to go for Bourdon tube pressure gauge, and which is used to measure a wide range of pressure which will be in the range up to some few thousand PSI. PSI is the unit for the measurement of pressure. The abbreviation for PSI is pounds per square inch. And generally when you are looking at the Bourdon tube, the shape which looks like a C-shaped hollow tube, and it consisting of two ends, and one end will be fixed and the other end will be connected to some other component. So one end is fixed and connected to the pressure tapping, on the other end is free, and the materials used for this board-on tube is phosphorus, brass and beryllium copper. So the overall diameter of the C tube, it is from 2 inches to 18, and C-type tubes are generally commonly used. In industry also, the board-on tube pressure gauges are using, and there are some different types of board-on tubes. They are called helical, twisted or spiral. So the twisted is, or we can call it as a spiral. So these are the different types of board-on tubes we have. You can just look at the diagram. This is what I told you. It looks like in C shape, and which consists of a pointer, then scale. You have a spring, linkage mechanism, gearing arrangement, and you can just look at the tube construction. Free end of the tube, the another end where we are going to apply the pressure. So that is what the indication of the arrow, that is P. So the other diagram which gives how the cross section of the tubes, and the cross section is look like an elliptical. So when a pressure is applied, what will happen? There will be an elongation. So there will be some variation will happen according to the circular shape. So automatically it will get upward, or else it will getting into downward. So what will happen when the pressure is applying through the inlet downwards? The upper portion, you have the free end which connected via deflecting mechanism, connected through pointer and the scale. So what will happen if the upper portion is getting moved? Automatically the pointer will get deflected. So there will be a stress developed and the tube tries to straighten up. So the free end of the tube moves up. Depends on the magnitude of the pressure, your pointer will get moved. So the deflecting and the indicating mechanism is attached to the free end that rotates the pointer. So the pointer which is connected through deflecting mechanism of the free end of the tube. This is what the construction of your diaphragm, elastic, pressure, transducer. You can just look at here the board-on tube different configuration. The first one is C-type, second one is spiral, and the third one is helical. So you can just look at the C-type board-on tube. It look as it like in C. The downwards you have an inlet. That is what your process pressure. Next one is your spiral, and the center portion it consists of an pointer section. Next one is a helical, which is nothing but the combination of linear and the spiral motion. So helical, which gives both rotation as well as linear motion, and which consists of a moving tip. So the next one is about what are all the advantages and disadvantages of this board-on. So when you are looking at the advantage, it is low cost, simple constructions, and variety of ranges available. For very high measurements also we can go. The disadvantages, it consists of a spring. Because of that, there will be a problem of shock as well as vibration. The next one is about the diaphragm. The diaphragm, it is another elastic pressure transducer. There are three different types: thin plate, membrane, then corrugated diaphragm. And these are all the classifications are based on the applied pressure. Accordingly, there will be a displacement. Just look at the diagram. The diagram which shows a thin plate. The downward you can look, the indications are pressure. So when the pressure is applied, automatically the down portion will get rise into the upper. So automatically the thickness will be lesser. So it is made up of the machining of solid block, and making a circular cross-sectional area with smaller thickness in the middle portion. That is how they are measuring the pressure in the diaphragm. So this is the next type. This type, you have a sensing section which is connected to solid blocks. You can able to see the right and the left, you have two solid blocks which is connected a membrane, and it's like a string, it's a wire. So when the pressure is applied, automatically in between the string there will be some changes where happen. So where the thickness is very smaller, so when pressure is applied on one side and the displacement is getting larger, so the sensitivity is very less. That is the reason they are going for another type that is called corrugated. So corrugated one, which is nothing but the same thing, you have two sides. Inside there is some indication, that is what call it as in corrugated. So the corrugated, we are just going to apply the pressure, that is what the indication of P. Just look at the other diagram. So when there is an elongation, there will be a bending motion. That is what I have indicated. So a large deflection can obtain for a small change in pressure. And the material used is bronze, brass, stainless steel. But recently they are using silicon, and moreover, you all know the recent technology is MEMS. The MEMS sensor for pressure measurement, micro electromechanical system. Here they have used the material is silicon, and they are getting diaphragm type of pressure transducer. The next one is how the frequency is calculated. So Fn, which is equal to 1 by 2 pi into root of K by M equivalent. M equivalent, which is nothing but equivalent mass. K is an elastic constant. So here the operating frequency is always less than that of the natural frequency of the diaphragm. So accordingly we have to design. Then here I have listed some two equations. They are all based on the types what we are going to use. The first equation is about the thin plate, that is Y0, which is 3 by 16 rho of 1 minus V squared by Et cube into R power 4. So here the V is Poisson ratio and E is modulus of elasticity. Then the next expression is the next type, and in which the membrane, the deflection is getting larger, then automatically we have to getting into the expression P is 3.58 Et cube by R power 4 into Y0 power 3. So where Y0 is means what? The Y0, which is nothing but the maximum deflection which is occur in the center portion. When a pressure is applied, there will be a deflection. That is what the indication of your Y0. And sigma max, which is nothing but the stress developed by the material. So according to the material, the stress value is getting varied. The third one, your corrugated type. The corrugated type is a non-linear nature, so they couldn't able to get the expression. So they are not depends on the expression for the third type. So what are the advantage and disadvantage? Advantage, cost is moderate, adaptable for differential pressure measurement, good linearity. Disadvantage, it is lack of vibration and the shock. So it is difficult once if it is getting damaged, it is not easy to repair the thing. The third one is about the bellows. So just look at the diagram at the bottom. This is how the bellows look. So one end is free, the other end is fixed. The other end is fixed via your spring. The down portion X. The X is the indication of the displacement. So how far when the pressure is applied, how far there is a displacement occur in your bellow. And the bellows are made with number of convolution from a soft material. And here number of convolutions we have, it varies from 5 to 20. And they are measuring through A equal to K into X. Advantage, moderate cost, high force, adaptable. It is unsuitable for the measurement of high pressure. So when you are looking at this bellows, material used, passivafrons, brass, beryllium, copper. So A equal to Kx, according to the expression, they are just calculating the pressure using this bellow type.